Hello, I'm Paul Dowding, co-founder and head of design for Alfres Core, where we license and sell a differentiating layer one protocol called Tapestry X. I wanted to thank FinTechWomenUSA for inviting me to speak. Unfortunately, when I couldn't make it, they asked me to make a video. The video was to cover what is blockchain and distributed ledger technology, how transactions and blockchain DLT have challenges, blockchain and DLT opportunities for fintech, and blockchain and DLT solution considerations. They then told me that if I could cover that in 6 minutes. So here we go. Although the origins of blockchain are often assumed to be related to Bitcoin, it actually references back to a 1982 white paper by David Chaum called Computer Systems Established, Maintained, and Trusted by Mutually Suspicious Groups. And the first ever blockchain was actually created in 1991 by Stuart Haber and Scott Stornetta. And their white papers and articles at the time were cited in the famous 2008 Bitcoin white paper by Satoshi Nakamoto. The goal was to create append-only corrupt evident database updates. The hash linking of the data generated a sophisticated checksum in parallel with sequentially updated data and their respective timestamps. If the data is changed at any point, the subsequent hash links do not match and the error or corruption is evident. In a distributed ledger, each node has a copy of the blockchain, so a corruption or error would have to be replicated and accepted in each copy, or greater than a third according to Byzantine fault tolerance. This is extremely difficult to corrupt, except at the point where the block is created. Node 2 could pay Node 1 while simultaneously showing the same balance to Node 4 before the ledger is updated. This is known as the double spend problem. Scott Stornetta thought this was a problem because to resolve the double spend, you could check the update, but then who checks the checker, the checker's checker, the checker's checker's checker ad infinitum. But then he realized with enough participation, there could be consensus on the correct update. This is the origin of Bitcoin's mining, consensus algorithms, Ethereum's proof of stake, various forms of proof of authority, and other means of DLT network synchronization. Now let's look at transacting networks and DLT challenges. Blockchains or DLT networks are transacting networks without the central authority or some central clearinghouse. For any transacting network, two major problems are the lack of interoperability and the cost of errors and exceptions. The networks are often dedicated and customized to their use cases, and networks have optimistic processing, which require expensive reactive controls and exception processing. Dedicated customized networks can't transact with each other, have inflexible central counterparties, and create systemic risks to their centralization. Even money, the most fungible of assets, transfers through dedicated centralized networks. The potential solution is a consistent transaction protocol. And that's some of the potential of blockchains and distributed ledgers. When you look at a transaction, it has a multi-step life cycle. You agree the transaction with your counterparty, you record the transaction through the authority, you settle it, you reconcile it, and then later on you account or audit the records. These multi-step processes is where the costly retroactive fixing of exceptions, errors, and the fraud occur. There's also latency of days, weeks, or months, increasing costs and risks. The potential solution is to compress the entire life cycle to real time or as short as possible. Now, current blockchains were supposed to be the solution, but remember, an entire distributed ledger history can be downloaded and validated by a user on their own. But the next block of data requires a committee of consensus to decide it's good. And again, this is primarily for the double spend, which we described before. The problem is that consensus is a multi-person, multi-step process. When you look at the collection of the consensus, you can see the latency in the process, the computational scalability because it expands on two factors exponentially, the capacity throughput issue in terms of getting these processes done. And then because of the continuous linking of the hash links, you actually have memory scalability of keeping the entire ledger in the active memory from the genesis block to the current date. So current blockchains were supposed to be the solution, but the protocols cannot interoperate with other protocols or legacy infrastructure. They have capacity, scalability, and latency issues that do not always meet the use case needs, and they lack the functionality for ease of adoption. So while this may look like a problem, it's actually where some of the opportunities are for fintech. So looking at blockchain and DLT as opportunities for fintech, let's consider the following. There is the potential to increase the performance and scalability of the layer 1 protocols. So that's one area. You can have layer 2 protocols that sit above the current blockchains protocols and help with interoperability and functionality. And then if blockchains become the transacting protocol, like the internet protocol was for communication, then there's a whole new types of applications that could be developed to leverage this technology and sit above these blockchain solutions. So those are the three areas where the fintech can focus on in using blockchain. So what are the considerations for your fintech blockchain or DLT solution? Well, looking at the use case, you may consider operations, the financial aspects, legal and regulatory, and technology. For operations, you want to consider capacity, controls, efficiency, and flexibility. For legal and regulatory, compliance, regulatory reporting, and very importantly, the accounting, audit, and reconciliation standards. For the financial, what are the user benefits? How are they going to benefit financially? How is the business going to benefit financially? And also, is it financially sustainable? And then the various risks associated. And we've seen that with the current, some headlines, recent headlines in crypto and DeFi and exchanges. And the technology, is it secure? Is it scalable? Does it have the functionality to meet the use case? And does it operate at a viable cost? So these are the things that you can consider in assessing your fintech solution. Well, thank you again for inviting me to speak and make this recording. I hope the information was useful. I hope it helps with your analyzing your use cases, and I wish you well for the rest of the event. Thank you.